Welcome, and today on the workbench we're going to look at a Ramsey PR-2 LNA, which stands for low noise amplifier. This is a 25 dB gain amplifier which goes from 10 megahertz to 1 gigahertz. At the time of this recording, I'm not sure where I saw my reference, but in one reference in researching this, I did find that it said that it was good up to 2 gigahertz, but it was guaranteed to 1 gigahertz. In today's video, we're going to test to see if we could find what kind of range we're getting out of this, as I have great plans for using this device. One other note I forgot to mention, brand new, this sold for $44 for this complete package that you're seeing here, the device and the power supply. If you did not want the power supply, then that could save you $10. This device came out in around 1985-ish. I'm really not sure exactly the time frame. I know the device sold for around 10 plus years. My version here, I do believe, is a earlier version, but I could be slightly askewed. As you see here, my package, I do have the device and the power supply. One thing we will also do is we'll crack it open and see what it's made out of. The device uses a monolithic microwave integrated circuit amplifier IC, or a MMIC, a UPC 1678 MMIC. It requires 5 volts to operate. However, they give you a 12 volt power supply, and you could also put this in your vehicle if you wanted to hook this up to your scanner or to your FM stereo or other device within that spectrum. Now, it also says that it really doesn't matter what is positive and what is negative on this, because it does use a full bridge rectifier. However, it does state that the BNC connectors are at ground potential. So you probably just want to go by rule of thumb for back in the day, where we had the outside jack as negative and the inside as positive. As you can see, this is a real small unit, not very big. Did not measure it. It's probably about 3 inches or so by a couple inches by inch or so thick. Nothing major. We got sports 2 BNCs, an innie and an outie, and then we do have a power LED light. We do have our power input and a couple of screws, and the final test was okay, which is okay in my book. And that's it on this device. I've had this device now for approximately 4 or 5 days. I've really been jonesing at to use it, but I've been trying really hard to contain myself, maintain myself, and try to do this on camera. There's been so many things I've just I tried to hold for the camera. I just couldn't do it, but I'm fighting the urge. I've been trolling for one of these devices for quite some time. Never been happy with the prices that they've rolled for. So trolling, finally got one at a price I was fat and happy with paying, which was $30 including shipping. So can't complain. As stated, they sold for $44 brand new, so as you can see, they still hold their value, because I see them go for around $30 just on their own, give or take. In this video, we're going to use a myriad of test gear to see what's happening. We're going to try to see if we could find a start point and a finish point, as well as the gain amplification. Now, yes, I do know that it will vary frequency to frequency. I comprehend that, but I would like to know where its peak is at, so when I do want to use it on the bench, I know if this is going to be the right tool for me to grab. We'll look at it on the O-scope, see what kind of signal, if we're going to clip or if we're going to amplify and have a really nice, beautiful signal. We will put it on the spectrum analyzer. My spectrum analyzer, however, only covers from 150 kilohertz all the way up to 1 gigahertz, plus or minus on the band, on the edges there. If I have to go higher or lower, we'll see what we can do. In case I need a attenuator, instead of grabbing a bunch of attenuator pads, I do have this wonderful Hewlett-Packard attenuator. And as you can see, it covers DC to 1 gigahertz. I've not really tested this out to see where its full potential is at, but this covers all the way up to 120 dB attenuation. So definitely an awesome tool. Haven't showed this on the channel before. I've had this for a while, and picked this up in a box of junk, and got a lot of cool stuff for a lot of cheap money, and couldn't be any fat and happier. Other devices that we will probably end up using for the test will be this amplifier here, which is not an amplifier. I don't know why I called it an amplifier. I wished it was, but it's not. It is a signal generator. This generator out of the box is guaranteed to go from 1 megahertz to 2.6 gigahertz. However, it does go a lot lower than that. I think it can go down to about 10 kilohertz, and it'll start falling off, which is going to be a fantastic test, because when this starts to fall off, will this amplifier pick it up and amplify the signal at such a low spectrum? Just in case we do go higher than, are able to go higher than our 2.4 gigahertz that we can generate out of this signal generator, we have this signal generator here. This signal generator here goes from 2 gigahertz all the way up to 18.5 gigahertz or 18.6 gigahertz, somewhere up in there. So we definitely got our bases covered. For our low spectrum, just in case we are able to go further than what this generator can go, we will use this generator right here. This is a B&K generator. It goes from half a hertz all the way up to 21.5 megahertz. And actually it might even go lower than half a hertz. I think it goes to 0.01 hertz. So definitely got our bases covered. As far as frequency counters are concerned, we are going to use my RAT3000. RAT3000 is a wonderful frequency counter, and one day I need to do a video exclusively on RAT3000, and maybe we'll talk about why we named it RAT3000. That frequency counter goes from about 10 hertz all the way to 2.4 gigahertz, and we are going to try to push its limits above the 2.4 gigahertz. Hopefully the amplifier is up for the task. That's what we're hoping. And as a backup frequency counter, we have my wonderful and one of my favorite frequency counters. This is a Leader LDC 825, and this goes up to, it's spec to go to 1 gigahertz. However, I have got it to go a little higher, 1.1, 1.2 gigahertz. So we'll also, depending if the amplifier is able to push, we'll check to see how high up we can get that frequency counter to read. And for coax, we're going to be using coax that's definitely up to the task. I forget the model number off the top of my head, but it's like R213 or something like that. I'll put it on the screen exactly what it is. It's definitely spec to go high enough. I think it's rated to go to like 4 gigs, 5 gigs. So it's definitely good enough, and it's a low loss coax. So with that said, let's go ahead and unwind this and plug it in, and we'll get to witness this fire up for the first time. The power supply model on this is model AC1, in case you're looking for one your own self, or ensure you got the right one. Again, this is 12 volts out at 250 milliamps. What I'm expecting to happen here is once we plug this in, that little red light will fire up. I'm hoping we don't let no smoke out. Fantastic, we got a light. Alright, so now we need to start with a source. And we'll start off with this signal generator here. Do apologize, the camera angles is not good enough, or not proper, but I think you could see it okay. Since the labeling on the amplifier starts off at 10 megahertz, even though the book says 1 megahertz, let's go ahead and just start this off at 10 megahertz. And we will start off with a small enough signal. Let's go ahead and say 10 millivolts. And let's see if that's enough to excite the amplifier. And so next we'll take that cable and we will plug it into the spectrum analyzer, just so we could use this as our reference point. And so now I need to put my center frequency at 10 megahertz. Let me put a marker at 10 megahertz. Okay, so we see our signal right here. Let's go ahead and adjust our span so we can get a better look at that signal. Alright, so as you can see here, we are at 10 megahertz. We're at about negative 52. Negative 52 dB down. So then we're going to unplug the cable from here. We're going to plug it into the input. Then we'll take another cable, plug into the output. And then we'll plug this in. Wow. You could definitely tell we had a heck of a gain there. So that took us all the way up to negative 20, 26, 25. So that was about a 15 dB gain right there. So definitely an improvement. All right, let's go ahead and drop this down to, and that was only at 10 millivolts. You know what? Let's stay on this frequency, and let's drop that to 5 millivolts. We dropped the input signal by half, but it still maintained a really, really good signal. Let me go ahead and try taking this down as far as I can on this signal generator, which is only 4 millivolts as far as I can go. So as you can see, that's really, really awesome. All right, so let's go ahead and take this down to 1 megahertz. And then we will check our input, and we can see we don't, oh, let me change this to 1 meg. Yes. I say we didn't have a signal. There's our signal. Let's change our marker. Alright, so 1 meg, 4 millivolts in, we're getting roughly a negative 60 dB. And I forgot to mention the machine is set at 60 decibels. I'm sorry, the machine is set at 0 dB. The machine, the device will do the math for us if we needed to change the attenuation in there. Alright, so let's go ahead and unplug from there. Plug that into the amplifier. And what were we? Negative 60. And now we'll plug the output in. And we have a negative 30. So it doubled our signal. Alright, so 1 megahertz. This is awesome. So what does this mean? This means that it will also work, this amplifier will also work while working on radios. And that's one nice thing about having these LNAs, is you could get in and work with your oscillators and stuff like that. Get in there with your probes and sniff out the oscillator signals and the mixer signals and amplify it, so it is something that can be seen. So that's one of the many reasons why I wanted this. I do have HP amplifiers, but they're only I think they're only a 10 dB amplifier. So this here is going to be nice. So let's go ahead and drop the signal down to 500,000 hertz. Alright, so there's our signal. This is at this is at 4 millivolts going through the amplifier, and it's a really good clean signal. And we are a lot lower than what specs say, even if we looked at the manual at 1 meg. So let's go ahead and unplug, and let's look at our test. So here we are at a negative 60, and I believe we were at a negative 30 through the amplifier. So it's definitely doubling our signal. That is really, really good. So now what I'm going to do is take the signal generator. We're going to leave the device here set at 0 dB for our floor. And we're going to drive this down until it's flat, or we can barely see it, or something like that. So right now we're at 500 kilohertz. And to save time, especially editing, let me just push buttons and holler out. So there's 400. Now this is going to be really challenging because I have to wigwag like this. My device here unfortunately does not have a really wide spectrum. Well, let's see here. Alright, so 50 kilohertz is my maximum bandwidth. Alright, so we're at 400 kilohertz, 300 kilohertz, 200 kilohertz, and as you can see, we're nearing the edge. Like I said, this device is only good up to 150, but I have seen it go down even lower. And there's 100. That bump right there is us. So with that said, let's go ahead and let's see if I can get a measurement on that. Alright, so it's showing that we've got a negative 60. Plug this into the amplifier and the amplifier back in. Wow, I wasn't expecting that. But that's not our 100, so let's see what that is. That's a negative 500, 492 kilohertz. So could that be a, let's unplug the generator. Yep, so that's coming from the generator. So some kind of spurious emission, but we have lost our signal here. Let me increase the voltage on the generator until we start seeing if we see a signal. So that's at 50 millivolts. Let me take our marker back to 100. And I'm going to change my spacing on millivolts so we can speed that up. Oops. Wrong one. Alright, here we go. Well, we could definitely see it growing. We're at 290 millivolts there. So at 70 millivolts is when we could start seeing it increase. Again, going through the amplifier. Bypass the amplifier. And there's our signal. Alright, so with that said, what we want to do is let's see if we could sweep the bottom end. And for that, we'll set up our generator for sweep. We know it's good to 1 megahertz. We know it's good to 200 kilohertz, so let's just make this 200 kilohertz. Turn down my voltage, we don't need that much. Let's just go ahead and do 100 millivolts. And I will probably need to play with the time, but let's get it connected to the machine. Alright, so here is the device. Let me see if I can change my span. Nope, 50 is it. So 3, 250, 2, 150. So we're not going to hit the bottom. So if I change my center to 200, oops. And see, we lose our spacing. Let me change this to 5 megs. And then our span. So then our divisions become 1 meg each. So 5, 4, 3, 2, 1, 0. definitely want to need a better generator or spectrum analyzer. Alright, so I decided to go ahead and just set the center frequency up for 1 megs. And we'll just do our best at looking at this. So let's do a finish setting this up. And so what we're going to do is max hold. I'm going to turn that on. Alright, so now it'll build a profile. So this right here should be our wall, our beginning, our 0. Or pretty close to it. Okay, so again, this is not through the amplifier, but we could see where the knee, where we start coming in. Let me see if I could do markers in this mode. So it looks like at this junction right here, it's about 22 hertz or thereabout, if we're reading that right. Alright, so now we'll go through the amplifier. We see where we started on that one. And it don't look quite as good on this one. All right, so let's actually do delta markers. So about 480 hertz. So yeah, not bad. All right, so let's go ahead and look at top end. All right, and so for the top end, we're going to go to, well, because the spectrum analyzer only goes to 1 gig, let's go ahead and put this at 1 gigahertz. And we're going to start off at negative 110 dB or 1 microvolt. And let's go ahead and set this up to 1 gigahertz, so that's 1000 megahertz. And then we'll get ourselves a marker for 1000 megahertz. And then I will turn up the signal generator until we get a signal. All right, so that That signal there is reading at about a negative, well, it's kind of jumbly, say negative 75 dB. And let's go ahead and run that through the amplifier and let's see what happens. Oops. And there we go. Saying negative 71, 72. So not a big gain there at all. In fact, there was no gain, no change. Negative 75, 76. A little change. Little, but not by much. Alright, so what I've done here is I set the span for maximum, which is 10 megahertz, 20 megahertz, and we can see our signal right there, that little bump on the signal generator. I'm going to go ahead and twizzle it until we lose the signal. Which is right about here. So let's see if we can get a reading on that. That's about 1.6 gig, 1.06 gig. Wow. Let's bypass the amplifier. Very marginal did it pop up. So okay, so we know that it's not going to do 2 gigs. So with that, let's go ahead and set our signal generator for 500 megs. We'll turn our power down all the way. We'll set our spectrum analyzer for 500 megahertz. Center frequency, our marker at 500. We'll bump our span down. To 5 kilohertz. And as you can see, we do indeed have a signal. And that's going straight from the generator into the device here. So we're at about a negative, let's go with say 71-ish. And let's go through the amplifier. Well, we got a little bump there, don't we? And then we got a bigger bump. Let's change that frequency so we can get away from that spike. Let's go to how about 525 megahertz. Okay, so it looks clean. Marker 525. Okay. signal generator. All right, 525. We have no signal. Let me adjust the generator until we do get a signal. All right, there we have a signal at about -75. Let's go ahead and bypass that into the amplifier. Oh yeah, that made a difference. So we went from about -75 to a -51. So that's our what? Our 25 dB gain right there. Okay. Looks good. Let's see what it looks like on the scope. So we're taking the same signal we just saw on the spectrum analyzer and plugging it directly into the scope. And let's hit our little blue button. Okay, so that looks really good. So how you reading this? This is our sine wave, as you would see on a normal scope. Down here is our power level. Down here is our spectrum analyzer. And of course we can't trust the frequency at this range, but 360 hertz it's saying. There we go. There's our signal. (120 hertz). Alright, and so now let's go ahead and remove the bypass the amplifier. So we can see that it's going all the way to the top of the greticules. Absolutely nothing. So the amplifier definitely worked on this small signal into the scope. So that's awesome. And so there's the signal again. And so that's where we're at with the output on the signal generator. Let's see if this works on a frequency counter. Leave the settings exactly where we're at. So we'll just simply unplug it from the scope and plug it directly into the frequency counter. It should read 525 megahertz. And it's not. So let's bypass the amplifier. And as you can see, we're not even getting a reading. So it does show that the amplifier is trying to amplify the signal. With that theory, let's go ahead and unplug. Plug it back into the amplifier, and then we'll change the settings on the generator until we do get a signal lock in. Let's go ahead and unplug it from the frequency counter, plug it into here so we can get a reading. That's negative 21 dB going through the amplifier. Let's bypass the amplifier. Out of the generator, we're getting a negative 48, 49. Let's go ahead and plug it in. And no reading. So, another reason to have the amplifiers. As you can see, it definitely works. And a glutton for punishment. Let's go ahead and take this up to 2 gigahertz. We are going through the amplifier. We're still at our settings here. And this is the mess that we're getting on screen. Let me go ahead and turn up the generator. See if we get something to lock in. Signal generator is giving it all that it has, and I'm not getting a reading on this. Let's go ahead and bypass and go direct. And there's our 2 gig signal. Let me turn the generator back down. So I had to, on this generator, in order to get the frequency counter to lock in, as you see, I had to go all the way up to plus 30 or plus 3, however you want to say it. Okay, so we can see that this amplifier definitely does work. Unfortunately, it's not quite as wideband on the high end as I was kind of hoping for, but at least it does go up to 1 gig and takes you way down below AM radio signals. So I think the device is going to work out just fine on the workbench. I don't think I'm going to need to sniff out signals quite so high. It's more low frequency that I'm after, and we saw about a 15 dB gain, so that's good. It's definitely a little higher gain than my HP amplifiers are. Like I said, I think they're a 10 dB gain. This one's a little bit more easier to hook up and play with than that one is. Definitely a great asset for the workbench. All right, so the next thing that we want to do is, let me go ahead and turn all this off. And then we'll open it up and we'll see what it's all about. Okay, got everything turned off, powered down. To save about 29 nanoseconds of time, I went ahead and removed all 4 screws. All 4 screws are just simply flathead. One thing to note, time between this clip and last clip, a couple hours. I stepped away and had some things to do and came back, and all the while I left this plugged in, and I noted when I came back that these BNC connectors was rather warm. Not burn your fingers off warm, but noticeably warm. So I would think it wouldn't be best to leave this plugged in and walk away from it for the next 20 years. I'd keep an eyeball on it. Anyway, went ahead and pulled the screws out as stated, and let's go ahead and crack it open and see what happens. I've not seen inside this. This will be the first time with you. Okay. Not what I was expecting. And definitely a lot different than what the schematic shows. The schematic said that it had a full bridge rectifier, and I'm not seeing that. We do have 2 filter capacitors. (16 volt) at 100 microfarad on both of them. And as you see, we got 2 resistors up underneath there and a capacitor. And then we see we've got a grounding strap coming from this chip down to the TNC, or not, the BNC. Whoops, 2 different things. This chip reminds me of a modern day battery. All fat and poofy. But it is firm. It is potted. And can't really get it in camera, but you see there is some text there. And I cannot read it in person, and I really can't read it on screen. Maybe it said knee-high, I don't know. Well, definitely a custom part. I'd say if this dies, there's no repairing it. Interesting. If we look at the case here, on either side, you see that there are provisions to hang this up. If you were to finish notching that out, the other side, well, get the light right, you could see the outline of them. Thank you for watching. Do appreciate it. More vintage gear to come your way, I'm sure, in the next video. Thanks for watching. See you later.